Many globe earthers love to point at lunar eclipses and act as if they were solid proof that the Earth is a globe. The problem is, they don't prove it's a globe. Let me show you. Here I have a ball, and I'm going to cast the shadow of this ball onto another ball. Right? Look carefully at the shape of that shadow. Now here's the shadow of a ball being cast onto a plate. And please take notice of how the shadow is different here. Here's the shadow on a ball, shadow on the plate. Now here's a picture of a lunar eclipse. I don't know about you, but I think this presents a problem for the globe Earth model.
What's happening in that case is that the sun is on one side of the Earth is in the middle, and it's casting a shadow. The Earth is casting a shadow on the moon. And as the shadow moves across the moon, you'll notice that the shadow is curved, it's round. So something like the sun that's bigger than the Earth and is able to cast a shadow of the Earth on the moon can actually show you the shape of the Earth.
Yeah, that's definitely a problem for the globe Earth model.
Would every now and then cast a shadow on the moon. And when it did, that shadow was always round. Now, the only shape we know of that always casts a round shadow is a ball.
Wow, really, Bill? You had to project a flat image of the moon onto the wall in order to get your round shadow? And, let's not get started on the size of your shadow there. But what was that you just said?
Now, the only shape we know of that always casts a round shadow is a ball.
The only shape that can cast a shadow that's curved from any direction you put the light is a sphere.
Oh no, not you too! Not today, doctors. Not today. Please notice how that shadow appeared flat the entire time it moved across the surface of the ball. Now this leaves the question, why do we see so many curved shadows across the face of the moon? Does this mean the moon is actually flat? I suppose that is one explanation for this. But I don't think it's the shadow of the Earth being cast on the moon here. I think something else is going on. The shadow of the Earth is not the only thing that could cause the moon to turn dark. What if this has to do with some kind of a filter that comes between the Earth and the moon? And you know how I'm always on the hunt for common ground. Here I found some common ground with Colorado State University, wherein they acknowledge the fact that the light from the sun gets polarized as it passes through the atmosphere. And they further claim that bees actually depend on this polarization for navigation. That is pretty wild and mind-blowing if you ask me. Pretty cool, right? Animals are awesome. As I understand it, magnetic fields are generally pretty round. And keep in mind, the moon has its own magnetic field, and magnetic fields can also polarize light. So what would happen if we were to look at this through round filters instead of rectangular ones? Ooh yeah, bada boom bada bing! And you want to know what the most beautiful thing about this hypothesis is? It is easily testable. Just bring out a third filter and see if you can't bring the moon back into view during the next lunar eclipse. All it takes is a piece of tape. This phenomenon is one of the most mind-blowing things about polarized filters. But please know that this is not the only hypothesis of what else could be going on here. Please keep in mind, refraction can also cause shadows to appear. While I do not currently know the exact cause of lunar eclipses, I know I can say with confidence that they are not caused by the shadow of the Earth. And I'm not just saying that because the shadow of a ball being cast onto another ball is a straight line. One very important vocabulary word that everyone interested in lunar eclipses should learn is the word selenelian. This is kind of an essential term for flat earthers to know. A selenelian is a lunar eclipse that takes place while the sun is visible. And this particular multiple exposure image was featured in the NBC News back in 2014. Though if you want to look up that particular lunar eclipse, the photo was actually taken in December of 2011. Anyway, according to the description here, this photo shows the setting moon just as the sun was about to rise. So the moon is going down in the west, and the sun is coming up behind the observer in the east. And please notice how the moon is being lit up from the bottom up. Now let's try and visualize how the mechanics of this would work in Dr. Thaler's globe Earth model. If we were to put the eclipsing moon in here, where should we put it? Should we put it here? That doesn't seem right. The moon here is setting and should be moving into the shadow, in which case the light here appears to be on the wrong side. How about somewhere down here in the bottom half of the shadow? That looks a little better. The number one explanation I have heard globe earthers provide when trying to explain selenelians is that refraction is causing both the sun and the moon to be visible. That is some pretty extreme refraction if you ask me. High above the mountains even. And look, that moon is not showing any signs of distortion. I'm glad that we can agree that refraction is possible so high up in the air without any signs of distortion. That is some pretty significant common ground right there. Our flat Earth model actually depends on this kind of refraction taking place this high up. It is essential in explaining how sunsets work on the flat Earth. However, when we put the moon down here on the globe model, in order for the shadow to get bigger here, the moon would have to be moving into the shadow, not away from it. In which case, this would require the moon to be moving the wrong way. And this is a moon set, not a moon rise. But something else to keep in mind is that the sun moves faster than the moon does. In which case, as the sun goes up, the shadow should go down. That seems better. But just remember, if that is the story they want to go with, they can't accept that without also accepting the mechanics behind our explanations of how refraction can cause boats to sink on the horizon, as well as our explanations for how sunsets work on the flat Earth. The number one argument I continually hear against that is, if the sun was setting due to refraction, it would cause it to look distorted. I'm glad that we can finally agree that an object can be refracted without obvious distortion. That for certain makes this really valuable common ground.